Something old, older than our world, has just brushed past our sun. It arrived without a name, carrying a chemistry our skies have never breathed. Sensors saw it flare in a way that made even seasoned astronomers go quiet. Some call it an interstellar snowball, others think the story is stranger. Tonight we follow the trail of a visitor with no return ticket, and we'll hear what Elon Musk revealed about it on Joe Rogan's podcast. They didn't notice it because it was bright. They noticed it because it refused to behave like anything born under our sun. Night after night, the Atlas survey rakes the sky with the patience of a metronome, looking for the subtle crawl of things that don't belong. Rocks on collision courses, icy strays, faint smudges where last night there was only darkness. It's meant to raise alarms, not goosebumps. But when the motion of that smudge was fed into the orbit solver, the math came back with a shape that makes astronomers sit up straighter. Not a stretched ellipse, not a long lazy loop, but a clean hyperbola. Translation: this traveller isn't ours. It came from the dark between the stars, and it will leave for the dark between the stars. For a few hours, the object was just a string of coordinates and a whisper of light, a ghost drifting across a CCD. Then the follow-ups began. Observatories on other continents nudged their mirrors and gathered more photons. Each new measurement shortened the error bars and sharpened the verdict. The eccentricity, the measure of how unelliptical a path is, pushed past the threshold that locks you to the sun. This thing was going too fast to be captured by gravity. A visitor, not a resident. Never seen here before, never seen here again. Someone typed a provisional name into the shared ephemeris, and with it came a second jolt. 3i Atlas. The I is the mark our textbooks reserve for interstellar interlopers. The 3 means we've only done this twice before in recorded history. You can feel the weight of that number even if you don't speak the language of orbital mechanics. We live under a sky so old we treat it as permanent, and then, occasionally something arrives that reminds us the galaxy is a road, not a wall. After the designation came the ritual. Quiet, methodical, strangely intimate. Spectrographs open their mouths to drink the object's colour and dissect the light into clues. Was it throwing off gas? Was the surface carbon-rich or dust-coated? Did sunlight wake it up as it approached, teasing out a faint coma of vapour, or did it remain a dark stone slipping by on momentum alone? The first drafts of those answers would take time, but even without chemistry, the orbit alone felt like an introduction. Its trajectory was steep and decisive, an arrow that had been flying long before humankind learned to look up and ask, from where? For the public there was no spectacle, no neon smear across the dawn, no great tail cracking the horizon. If you went outside and craned your neck, the sky would not reward you with drama. 3i Atlas was too far, too small, too dim, and moving on a track that kept it safely removed from the inner blur of planets. That, in its own way, added to the eeriness. The most important things are often the quietest. You can miss a revelation if you only listen for thunder. Inside the data streams, though, you could hear the murmurs. Orbit fitters swapped plots showing the hyperbolic excess velocity, the leftover speed this thing would carry after shrugging off the sun's pull. Dynamicists traced the arrow backward, not to a specific star, but to a general quadrant of possibility, like tracking a single snowflake back to a storm. The conclusion was at once humble and profound. This is a scrap of someone else's beginning. A shard from a planetary nursery that wasn't ours, tossed out by ancient gravitational games, wandering for who knows how many millions of years until our neighbourhood happened to be in the way. That's why astronomers get poetic about visitors like this. Not because they think they're alien ships or secret messages, but because every grain of dust blowing off an interstellar object is a time capsule from a chemistry set we didn't assemble. In those particles are the proportions of water to carbon monoxide, the fingerprints of minerals annealed in a different sun's warmth, the story of what sticks together when worlds are first trying to be born. We don't have to catch the traveller to learn from it. We just have to listen as it passes. The name itself tells a story if you let it. Atlas isn't a brag. It's the system that found it. a pair of wide-field eyes built to spot threats early. It spends its nights being careful for the rest of us. When it tagged this object, there was no siren. The trajectory cleared Earth by a margin so generous you could fit entire orbits of Mars between us and it. Safety and mystery at the same time. The cosmos is kind that way more often than it gets credit for. For the script you're writing, don't be afraid to lean into the human scale of the discovery. Somewhere there were people refreshing dashboards at 3 a.m, watching error ellipses shrink as the new observations came in. Someone topped up a stale cup of coffee. Someone told a friend on a crackling phone line, "I think it's interstellar." That sentence lands like a bell. It changes the texture of the room. It turns ordinary work into a first page. If you want to bring viewers closer, explain the hyperbola without the math. Say, most comets are on ellipses, stretched circles, that keep them enslaved to the sun's pull. This one is on a shape that never closes. Think of it as a flyby. It came in fast, curves around the sun, and slings back out even faster, like a stone skipping once across a lake and disappearing into the fog. No braking, no capture, no second chances to look. And yet there's a paradox in that one-time glance. Sometimes you learn more from a passerby than from a neighbour. Because it doesn't belong here, 3i Atlas tells us what other star systems make with their raw cosmic dough. It challenges the lazy assumption that our recipe is normal. If its gases hum a slightly different tune under ultraviolet scrutiny, that difference is the headline. If its dust grains scatter light in an unexpected way, that surprise is a clue. Science advances not only on what we predicted correctly, but on the edge cases that refuse to fit. There's also sobriety to keep. Interstellar doesn't mean supernatural. We've met travellers before, and each time the non-gravitational quirks, little pushes from sun-warmed jets of vapour, made people argue late into the night. Those arguments are healthy. They're what happens when curiosity and discipline occupy the same table. As your narrative unfolds, you can honour both. The thrill of the unknown and the patience required to turn thrill into knowledge. So hold the shot on that wordless speck, drifting across a black frame filled with more black. Let the music breathe. Tell your audience that this is what a cosmic message looks like in real life. A smear barely brighter than noise, carrying the drift of an elsewhere we'll never visit. Tell them the sky's a highway, and, for a handful of weeks, a traveller with no return ticket passed within earshot. We won't see it again. We won't need to. It left something behind that only exists once you know to look for it, a new way of measuring our place. It didn't come to us out of emptiness. It rose along the crowded spine of the Milky Way, from a direction astronomers call the galactic heart. If you've ever seen that section of sky on a dry, dark night, Sagittarius and Scorpius braided together, you know it isn't black. It's thick with starlight, braided with dark riverbeds of dust. That's where the first streaks were logged. Not the easy part of the sky. The noisy part, the part where the background itself is alive. Southern observatories had the best angle at first. A mountaintop in Chile, a ridge in South Africa, a hill in Australia. Places where the Milky Way doesn't just arc overhead, it leans on you. Small teams and sleepless operators turn those star-packed frames into a nightly rhythm. Exposé, read out, a blink. Expose, read out, blink. Against that glimmering tapestry, the newcomer didn't announce itself with a flourish. It moved like a careful thought, a small displacement, a refusal to hold still. The survey pipeline flagged the tracklet because the motion didn't match the usual suspects. Someone clicked, follow up. Someone else sent 2 quiet emails with a subject line that carried more adrenaline than the text. Possible interstellar? Direction matters, but not the way you think. Seeing it inbound from near the galaxy's centre doesn't mean it was launched from the furnace of the core. Space doesn't give you straight lines you can trace back like string on a map. Over millions of years, gravity in our disk, stars, clusters, passing giants, plays pinball with anything loose. What the direction gave us was a mood and a challenge. The mood, or because we were watching a stranger step out of the brightest crowd we know. The challenge, confirmation. Because crowded fields make it easy to fool yourself. Ghosts appear when stars overlap. Noise pretends to be motion. The galaxy is a master of optical illusions. That first week, every new frame trimmed uncertainty. You could almost hear it, the way a room quiets when someone finally speaks plainly. Each night, the arc tightened into a trajectory. Each night, the path drew nearer to the plane where our planets keep their curb. The numbers, which we don't need to spell out here, told a simple story in ordinary words. Coming in fast, dipping close, leaving faster. A flyby, not a loop. A one-way letter dropped into our mailbox by a messenger who never breaks stride. And the messenger itself? That's where humility returned. From Earth, brightness is a treacherous clue. Is it dark and large, or small and bright? Does it wear a fresh coat of frost or an old sunburned crust? Without knowing how much sunlight it reflects, you can't translate glow into girth. Early estimates floated like everything else in those days, wide enough to fit two different futures. If the surface was soot black, it could be bigger. If it was icy clean, it could be smaller. Either way, it wasn't going to turn into a crowd pleaser. No blazing sword over the city. No tail curling across the news. For most of us, 3i Atlas would remain a rumour in the data, an arrow on a plot. The irony is perfect. To understand a thing from another star, we had to look through the most complicated place in our own sky. Telescopes switched to shorter exposures to keep the stars from smearing into mistakes. Image subtraction software learned the background like a song, then removed it, measure by measure, trying to leave only the soloist. The moment the background was peeled away, you could see it. A point that didn't belong, stepping between constellations like a traveller crossing a busy station without losing their pace. There's a romance to the phrase near the galactic centre, and it's worth a breath. That region is where our galaxy's bulge swells, where star clouds overlap, where you can sense the weight of billions of suns, even from this far-flung suburb where we live. You don't need to tell your viewers about coordinates or longitudes. Let them feel the geography. The Milky Way isn't a flat poster. It's a city of light with districts and thoroughfares, and the heart is most alive in the south. That's where 3i Atlas seemed to walk in from, like a stranger emerging from a crowded market. People love to ask, did it pass close? The answer is a paradox. In maps, yes, it crossed the same pages where we draw the inner planets. In life, no, it kept its distance. Think of a well-lit highway overpass you can see from your neighbourhood at night. The cars there are close in a human sense. You can watch them flow, but they never come down your street. That was 3i Atlas. Visible to the machines that knew where to look, invisible to the rest of us. Safe, aloof, doing its business without leaving a footprint. The southern vantage gave something else too. Steadiness. No late sunsets, no seasonal humidity draped over the Milky Way's midriff. Dry air, big mirrors, long nights. The first spectral hints rode in on that steadiness. Whispers of what the sunlight was bouncing off, the colour of the dust, the breath of gases set free as warmth seeped in. Even then, the team leads kept their language conservative. Consistent with a cometary nature, they wrote. In plain terms, not a polished stone, not a shard of metal, but the kind of object that sweats when it gets warm. A freezer-burned traveller that fogs the glass when you open the door. What does "from the south" mean to people who don't speak telescope? It means different stories at different latitudes. In the north, the apparition was always low, a rumour near the horizon, easy prey for haze and city glow. In the south, it was a citizen of the zenith, crossing the very crown of the sky in the small hours. There's a quiet privilege in that. Somewhere on a desert ridge, a technician stepped outside to warm their hands and looked up at the Milky Way so bright it cast a shadow. Inside, on the screen, the newcomer nudged 1 pixel over. Outside, a nightbird called twice, then went somewhere else. The world didn't know, but the world was different. Size. Let's come back to it without math. Imagine a dark car driving at night with its headlights off. Whether you judge its size by the small glow of the dashboard is guesswork. That was our problem with 3i Atlas. If the dashboard was inherently faint, the body could be bigger. If the material was reflective, the body could be smaller. Either way, it was enough to give us science without giving us a show. Enough to leave fingerprints on instruments without leaving memories in the unaided eye. There's a beautiful humility in navigating by the busier sky. Astronomers like the simple spaces because simple spaces make it easy to avoid mistakes. But sometimes the important things choose the complicated road. They make you earn them. They make you clean your data and check your hunches and ask a second team to run the numbers while you sleep. Coming from the direction of the galactic heart, 3i Atlas forced that discipline. Every claim had to be stripped of romance and rebuilt from what the pixels actually said. And still, let yourself keep a drop of romance. Because there's a reason we turn our cameras toward the Milky Way's bright centre every time we want to remember why we look up. It's the place where our galaxy stops being an idea and becomes a body, muscle, bone, pulse. That's the backdrop from which an interstellar stranger arrived. Not a headline streaking across your backyard, but a quiet crossing in front of the most crowded window we have. A small, precise movement that told a large, imprecise truth. The galaxy is busy, the roads between stars are real, and every so often something from those roads passes within earshot of our instruments and keeps going. 3i Atlas did not ask to be seen, it simply kept its appointment, coming in from the heart, leaving toward the dark, indifferent to everything except the deep grammar that moves all travelling things. Before anyone saw a tail, before any photograph showed drama, there was a smell in the light, faint, like breath on cold glass. Instruments designed to split starlight into clues found a small, stubborn signature riding with the glow of the sun. It wasn't loud, it didn't have to be. Water, when sunlight breaks it apart, leaves a calling card, fragments that fluoresce, whispering, "Ice is here." That's how the rumour began, not in headlines, but in the quiet of a spectrograph reading out numbers at 2 in the morning. 3i Atlas wasn't just passing through, it was waking up. Think of a comet as a sealed box that's been in a deep freezer for ages. Bring it into a warm room and you don't have to open the box to know what's inside. The surface fogs, the seams sweat, the air around it changes. 3i Atlas did the same thing on a stage the size of our solar system. As sunlight reached it, the topmost grains heated first. Tiny pockets of ancient ice, water frozen so long it has its own patience, began to vaporize. Gas slipped out through the porous crust, taking dust with it. Around the nucleus, a thin, temporary atmosphere formed, a coma so large that no camera would ever frame it whole. It's not an atmosphere like Earth's. It's more like a cloud haunted by a rock you can't quite see. To the human eye, that change is barely visible. To the right instruments, it's unmistakable. Water molecules hit sunlight, split, and their pieces shine in very specific shades. Those shades are how astronomers listen. You don't have to memorize the names. It's enough to know that comets speak a familiar dialect. 3i Atlas spoke it, softly at first. A rise in those lines. A hint of dust scattering light differently than bare rock would. Consistent with cometary activity, the dry note said, which is the cautious way of saying it's beginning to breathe. Breathing sounds gentle, but it's not timid. Gas escaping from sunlit vents behaves like miniature rockets, pushing on the nucleus. That push is tiny compared to gravity, but not zero. Over days and weeks, those little thrusts add up, tilting the path by a whisper. You can't watch the push happen. You can only see that the path fits better when you admit it exists. 3i Atlas wasn't steering. It was doing what thawing things do, exhaling, turning a little as it did, and leaving a trail of what it carried inside. The trail itself is 2 stories braided together. One is dust, slow, heavyish particles shed from the surface, curving away to form a broad, soft fan that sunlight pushes and gravity weighs down. The other is the ghostlier tail, gas-stripped and charged by sunlight, carried along by the solar wind into a tighter, straighter ribbon. Even if your eyes never catch those structures, your mind can hold a simple picture. Dust remembers where the comet has been. Gas points to where the wind is going. Three-Eye Atlas wrote both sentences in very small handwriting. What makes this breath special is not that it exists. Many comets breathe, but where it started. The ices in Three-Eye Atlas did not form here. They are the leftovers of another star's baby years, bottled by cold and time, altered by the radiation of empty space. The proportions of gases mixed into that ice, how much water, how much carbon monoxide, how much carbon dioxide, are a fingerprint from that other nursery. When the surface warmed and those molecules came loose, the fingerprint became legible. Not a complete biography, but a set of hints that say, the chemistry over there was like this. It is the closest we get to tasting rain from a different world. Early activity always looks patchy. Sunlight strikes one hillside before another. A crack opens here, a vent unseals there. Three-Eye Atlas likely spun slowly, presenting different faces to the sun, and every rotation arranged the jets into a changing pattern. If you could hover beside it, and you can't but imagine, you'd see a dark, rough surface with bright, brief feathers of vapour, fanning out from pits and cliffs, throwing off cinders. Up close it would smell like a comet smells, acrid, metallic, the breath of rocks that have never known air. From Earth, all of that reduces to a softened glow around a point, and a few lines in a spectrum that rise just enough to make the scientists nod. There's a temptation to treat water as a promise, but it's really a question. What kind of water? How clean? What's mixed in? Interstellar objects don't have to obey the averages we've measured in our own backyard. They might be richer in one volatile, poorer in another, shaped by heat at slightly different times, salted by different dust. That's the draw. Three-Eye Atlas gives us a comparison sample from a lab we didn't build. If its water carries more of one isotope than we expect, that matters. If its dust grains are a hair more glassy or more carbon heavy, that matters too. Science grows on these small tilts. None of this required Three-Eye Atlas to come close or shine bright. A few well-timed observations did the heavy lifting, some from the ground on nights steady enough to draw thin lines without wobble, some from space-based eyes that don't blink in the air. The pattern they built was a steady, quiet crescendo. No activity, then maybe, then yes, and then the slow climb toward a modest peak as the sun's warmth did its careful work. Not a firework, more like a kettle getting ready to sing. Even in that quiet, there are moments that feel personal. A technician watches a graph refresh and sees the small rise become a real rise. A postdoc writes, "detection tentative," in a draft, and then, 2 days later, deletes the adjective. A principal investigator practices saying, "we confirm," without letting it turn into, "we discovered the meaning of life." It's not theatrical, but it is human. The breath of Three-Eye Atlas crossed a gulf of space and nudged a handful of people into grins they tried to hide in professional emails. Of course, breath runs out. Cometary activity is a conversation with sunlight, lively as you approach, quieter as you leave. Three-Eye Atlas would not keep venting forever. The near-surface ices would deplete or crust over. Jets would fade. The coma would thin and sink back toward invisibility. The temporary atmosphere would collapse as if it had never been. That's part of the message too. These are not eternal fountains. They are one-time readings from bottles uncorked just long enough to sample. If you want to translate all this for your viewers, you can do it in a single honest image. Picture a brittle snowball that's crossed a desert for 1,000,000 years. It reaches the campfire. The side that faces the heat steams and hisses. A thin fog forms, carries the scent of what the snowball is made of, and drifts away on the wind. No one keeps the fog. but anyone standing nearby can tell you what they smelled. 3i Atlas was that snowball. Our instruments were the people around the fire. There's one more quiet reward in this breathing. It tests our assumptions about interstellar visitors without asking us to jump to wild conclusions. No need to invent engines or messages. Natural physics does plenty. Ice wakes in sunlight. Gas escapes. Dust follows. The path bends a little. The light changes colour. From those changes, a careful mind pulls out stories about distant disks and the recipes of other beginnings. It's humble work with grand consequences. So the chapter of breath is not an explosion, not a spectacle. It's a page of testimony signed in vapour. 3i Atlas came closer, sighed in sunlight, and, in that sigh, allowed us to hear the weather of another star's childhood. Then it kept going, as all travellers do, leaving us with a handful of lines on a plot, a few dust grains in the beam, and a larger idea of what home might mean in a galaxy full of kitchens we've never seen. Perihelion isn't a place on a map, it's an ordeal. It's the tight corner where the sun fills half the sky, and every buried secret has to decide whether to stay hidden or evaporate. As 3i Atlas arced inward, the usual observing routines began to fray. Ground-based telescopes lost their grip first, because the object was slipping too close to daylight, and the solar glare washed over everything like floodlights on a dark stage. The baton passed to the spacecraft that lived to stare at the sun. Their coronagraphs, machines that make artificial eclipses, blocked the star's face and let the surrounding halo come into view. In those black discs and pearly rings, watchers waited for a faint intruder to step into the frame. That's where the flare story belongs. Not as a single thunderclap, but as a few frames that made people lean forward. Brightness is supposed to climb in a tidy way as sunlight increases. Real comets roll their eyes at tidy. For days the curve was modest, then the numbers sharpened, then sudden tilt. 3i Atlas brightened faster than the earlier point suggested it would, like someone turned a dimmer switch with a twitch instead of a glide. There are two honest ways to read a flare like that, and they can both be true at once. The first is geometry. At small angles, when you're almost looking toward the sun along the same line as the object, dust can become far brighter than you'd expect. Picture walking into a room and seeing all the tiny particles in the air, only when the sunlight catches them just so. That just so angle near perihelion can make a thin veil of dust shine as if the comet suddenly grew a lamp. Nothing exploded. The stage lighting changed. The sun was behind 3i Atlas, and the dust between it and the cameras threw light forward like glitter. The second is physics with a pulse. Near perihelion, everything that can crack will crack. The dayside bakes, the nightside freezes. Old crusts that have held themselves together for millions of years start to groan like lake ice in spring. Vents uncap. Panels of brittle material slough off. Fresh ice that's been sealed under an insulating rind meets sunlight for the first time and flashes into gas. That gas claws at nearby dust and hurls it outward. If a new vent opens or a slab collapses, that's an outburst. It reads as a flare to our instruments because more reflecting stuff, fine dust, ice grains, suddenly fills the coma. In plain language, the comet coughs and you see the breath. You can hear the argument in the way the notes were written. Some insisted the flare belonged mostly to the geometry, forward scattering at work, nothing dramatic required. Others pointed to the timing and texture of the brightening and said, "There's a physical jolt in there." The truth is patient. 3i Atlas likely offered both gifts, the right angle to make dust sing and a handful of fresh dust tossed into the spotlight at the same time. There is a practical reason to care which story dominates. If geometry did most of the work, then 3i Atlas showed us how its dust is built, how grain sizes scatter light, whether they clump or float free, how quickly they fade once the angle passes. If an outburst did the heavy lifting, then we learned something about the nucleus, its crusty strength, its tendency to fracture, the way gas jets turn on and off. In both cases, the flare is a measurement, not a miracle. It's a stress test administered by the sun. Everyone who watches these passages has a favourite drama. One school roots for the spin-up tale. Jets don't just push outward, they torque like tiny thrusters on a tumbling spacecraft. As the torque builds, a weak, lumpy body can begin to rotate faster. If it spins too fast, bits, boulders, plates, gravel, can drift free. Not in a cinematic shatter, but in a soft unravelling. A flare can be the signature of that unseeming fresh surfaces suddenly staring at daylight. Another school likes thermal delamination, a mouthful that simply means the outer layers peel like old paint when heated, exposing bright gassy underlayers that puff and then quiet down. Neither requires catastrophe, both leave fingerprints in the light. Meanwhile, the clocks that matter are orbital, not human. Perihelion comes whether you've slept or not. In one set of images, 3-Eye Atlas is a cautious spark. In the next, it is decisively present. The halo around it looks thicker, the inner glow stronger, the suggestion of a tail sharper. The sun's wind, charged particles streaming outward, threads the gas into a slimmer, straighter ribbon, while radiation pressure, the faintest of breezes, combs the dust into a softer fan. In the tightest shots, you might convince yourself you see kinks, little bends that hint at jets, or waves that ride down the tail when the solar wind hiccups. You check yourself, because artifacts love to dress up as discoveries in this kind of data, but you keep watching. For people on Earth, there's a paradox in this whole chapter. The most dramatic changes happen when the comet is least visible to ordinary eyes. The sun swallows the stage, and only the specialised instruments can attend the play. That's why the flare feels intimate to the small community that caught it. It unfolded in a handful of frames, inside software windows that most of the world will never open. Somewhere a researcher muttered, "There it is," and took a screenshot that will live on a hard drive labelled with a sensible name and an unreasonable amount of affection. The aftermath is where the flare earns its second name, not just brightening but revealing. Fresh dust brightens and then dims as the geometry changes and the plume disperses. If you graph the light, the curve has a kink where the flare happened, then settles into a new slope. That kink is a fingerprint you can compare to other visitors. Does 3-Eye Atlas behave more like the classic icy bodies that have visited us from our own Oort cloud, or more like the earlier interstellar guests we've met? The answer arrives not as a headline, but as a cluster of points tightening around a quiet conclusion. That's the luxury of a one-way traveller. It forces you to learn fast. There's also the question that makes observers wince. Did it survive the turn? Some comets soften into ghosts after perihelion, as if the heat rearranged their insides and the structure lost its courage. Others emerge scuffed but intact, their activity tapering the way a fire tapers when you pull it away from a draft. 3-Eye Atlas kept moving either way, because gravity doesn't care about your complexion, but the shape of the fading tells you what kind of body it had. A sudden collapse in brightness hints at a breakup, or a complete exhaustion of easy venting. A graceful decline suggests a tougher skin and a slower leak. For storytellers, there's a temptation to make perihelion into a boss fight. It's cleaner to say it broke, or it triumphed. The reality is subtler and in a way richer. 3-Eye Atlas probably lost flakes and puffs, maybe a chunk, maybe nothing obvious at all. Only the flare and the curve it left behind to show that the sun asked a hard question and the visitor gave a complicated answer. Nature often speaks in partial sentences. We learn to listen between them. If you want to show viewers what this looks like without special effects, keep it simple. Picture a black disk hide in the sun. Around the edge of that disk, the corona ripples like fine silk. In that silk, a tiny seed of light slides, gathers a faint halo, and for a short stretch glows more than you expected. Then it keeps going, out of the glare, thinning as it goes, trailing a kind of memory behind it. That is the whole drama in one plain image: approach, flare, exit. And woven through all of it is the reminder that this isn't only spectacle, The flare is a probe we didn't have to build. It tells us how tightly dust clings to ice, how quickly cracks propagate when the day side bakes, how eager the nucleus is to vent when the lid pops. Multiply those clues by interstellar, and you have a laboratory report from another star's maternity ward. The flare is the moment the report printed legibly. After perihelion, the sky gives the object back to nighttime. Ground-based telescopes pick up the trail again, blinking star fields and subtracting backgrounds, measuring a comet that is now coasting away, cooling, buttoning its coat. The brightness no longer climbs, it steadies, then ebbs. People compare pre-perihelion and post-perihelion images like before and after photos. The coma looks looser. The tail is thinner. The core might be a hair fuzzier or exactly the same. Arguments soften into papers. Plots harden into conclusions. What remains for the rest of us is the shape of the story. 3i Atlas approached the sun, and in that furnace revealed something it had kept quiet over a long cold voyage. We couldn't walk up and touch it. We couldn't catch it in a net. But for a few days, as it rounded the corner, the combination of angle and heat, dust and breath turned a distant stone into a speaking thing. It flared. Not for us, really, but in our direction. And then it left, carrying its unsolved parts with it. The lesson is the same one the sky always teaches when we pay attention. The moments of greatest change often pass right next to the brightest light. If you want to see them, you have to learn how to look sideways. Joe asked the question the way non-astronomers always do, half wonder, half side-eye. What is this thing, really? Elon didn't reach for the spooky answer. He did what he does when he wants to puncture hype without killing curiosity. He zoomed out. Space, he said, is full of rocks that are not rocks the way we think of rocks. Many of them are nickel-iron, metal you could hear if you dropped it on a shop floor. A surprising share of the nickel we dig on Earth, he reminded Joe, is tangled up with ancient impacts, pieces of the sky folded into our crust. So when people hear visitor from another star and jump straight to aliens, they're skipping the better story, that the universe routinely throws raw materials between worlds. If 3i Atlas were mostly ice, and it probably is, the principle still holds. The solar system is a warehouse, and some of the stock is delivered from out of town. He didn't claim secret samples. He didn't claim secret ships. What he did was translate wonder into logistics. Interstellar objects like 3i Atlas barrel through too fast to rendezvous with using the hardware we have sitting on the pad today. But that speed isn't a cosmic no, it's a spec sheet. If you want to meet something like this one day, you need a fully reusable heavy lift vehicle, you need to refill in orbit, and you need to be ready to sprint. No 5-year build cycles after discovery, no committee naps. You can't chase a bullet with a tricycle, he said, and Joe laughed. But Musk's eyes didn't move. The subtext was simple. If you ever mean to examine a traveller like this up close, you must build the kind of system that makes quick, energetic missions normal. Then he did the other Musk thing. Connect the cosmic to the garage. Nickel matters here and now. The toughest alloys lean on it. High-performance batteries still like it, even as cheaper chemistry spread. If a future civilization mines in space, he said, it won't be so we can bathe in gold. It'll be because steel with the right mix becomes cheaper off-world than on it. You don't have to drag it all home either. Smelt in vacuum, weld without weather. Build the heavy things where heavy things are born. He sketched the outline with a mechanic's shorthand. Spin for gravity, heat with sunlight, separate by mass. No equations, just the hunch that a machine shop in orbit could look more like a farm than a foundry. Joe pushed on the big dramatic angle. Could 3i Atlas be a probe, a message, a test? Elon shrugged the showmanship off and parked the conversation in a place more interesting than certainty. Unlikely, he said, and not necessary. Nature already sends us gifts we can barely unwrap. A comet that breathes across our field of view is a laboratory we didn't have to pay for. If you want to find life, or build a frontier economy, or just understand your neighbourhood, you start by getting very good at intercepting and listening. Starship, he said, without saying the word every 2 minutes, exists because we're going to need a truck, not because he wants to build the world's biggest statue. Trucks carry labs. Trucks carry telescopes. Trucks let you hustle when the universe gives you a deadline. And in the quieter beats, between jokes about memes and cigars, he tucked in the part most people will miss on a first listen. Don't mistake spectacle for opportunity. 3i Atlas is not a target. It's a teacher. It proves traffic exists. It forces us to think in ready to go rather than someday. It's too fast now, but there will be slower ones or earlier detections, or a Sentry spacecraft already loitering in the outer system waiting for the alarm. When that happens, the difference between we learned from a distance and we touched it will be the difference between having built the boring infrastructure in time and having not. Romance, he implied, is a terrible project manager. What landed hardest wasn't any single claim. It was the tone, the way he let the air out of the balloon without removing the lift. The mystery of 3i Atlas didn't need embellishment. It needed context and a to-do list. You could almost hear people scribbling it down in the back of their minds. Survey better, move faster, make launch a routine, keep a chaser ready. He didn't say those exact words. He didn't need to. The outline wrote itself in the negative space around the hype everyone expected him to feed. Why that matters starts with the obvious and ends somewhere close to spiritual. On the obvious end, nickel is the skeleton inside the hard stuff. Turbines, valves, cryogenic plumbing, heat-beaten skins, all of them are happier when nickel is in the conversation. High-energy batteries that push range or performance still call for it. Even as cheaper, iron-based chemistries spread into the mass market, the frontier machines, the ones that fly higher, burn hotter, last longer, keep nickel on the guest list. If you imagine an economy that climbs off Earth, you imagine nickel in its bones. That's not a fetish. It's material science at room temperature. But metals are only half the story. Comets like 3i Atlas carry water, carbon compounds, and dust. Volatiles we can split for breathing and burning. Feedstocks we can turn into plastics and foams. Radiation shielding we can pile thick around habitats without paying a launch penalty to lift it all from sea level. When you realise a dirty snowball has more utility than romance, you stop treating a visitor like a curiosity and start treating it like a live demo. This is what a mobile gas station looks like. This is what a travelling parts bin looks like. You don't catch this one. You design for the next dozen. There's also an industrial elegance in moving heavy industry upstairs. Smelting in vacuum means your exhaust is the void. Solar heat is free if you learn how to hold it. Separating materials by how they respond to spin, light or magnetism becomes cleaner when gravity is optional. You can build furnaces that blossom from mirrors, crucibles that never rust because they never breathe, foundries that run on light and quiet. That's not sci-fi. It's simply taking the constraints off the bench and seeing what the bench wants to be. 3i Atlas, in exhaling across our instruments, gives you a shopping list. Water to crack, dust to sinter, trace metals to test. Resources stops being a slogan and becomes a diagram. And then there's the calendar. Interstellar visitors don't wait for budgets. They appear with the rudeness of weather. That's why the details in Elon's riff matter. Reusable flight, refilling in orbit, payloads that can idle on the shelf without expiring. It's not that this one got away. It's that the universe has told us twice and now 3 times that we live on a road. If we want to act like road people instead of porch people, we keep a go bag packed. A Sentinel spacecraft parked far from the sun's glare. A small armada of off-the-shelf instruments that can be bolted to a bus and launched on a Tuesday. The courage to accept enough science over perfect plans, because a moving target does not care about your PowerPoint. The why isn't only engineering, it's comparative biology at cosmic scale. When 3i Atlas breathes, it tells us the recipe used in another kitchen. If its water leans slightly heavy or light, if its carbon compounds skew this way or that, We redraw the map of how easy it is to make the ingredients of life everywhere, not just here. That's not a footnote for specialists. It's the backbone of the oldest question we ask when we stare at our ceiling at 3 in the morning. Are we alone? Behind that, more quietly, are we normal? Every interstellar sample, even a spectral one, chips at those questions with patient teeth. There's an environmental angle too, though it won't fit on a bumper sticker. If we ever move some mining off Earth, it won't be because our better angels suddenly grew wings. It will be because processes that poison or scar down here can be redesigned up there to be cleaner by default. Vacuum is a solvent nobody has to dump. Sunlight is a fuel nobody has to drill. Slag becomes a building block when gravity is negotiable. You don't extract to bring home. You extract to build where you stand. If that sounds utopian, look again. It's just physics with a conscience, applied where the geometry favours us instead of punishing us. And let's name the friction. Cost, politics, inertia. The math of asteroid mining on a spreadsheet here on Earth has never looked pretty. Launch was too expensive, timelines too long, markets too twitchy. Reusability has started to sand those numbers down, and refilling in orbit plans to sand them further, but the old instincts are not wrong. They're just calibrated to the past. The lesson of 3i Atlas is not profit tomorrow, it's train now. Survey deeper. Practice rendezvous with local comets and asteroids. Fly small missions that fail in the right way. Build factories that can live in the dark and breathe in vacuum. When an interstellar object waltzes by with months of warning instead of weeks, you want to be in a position where the hard part is choosing which ready-to-fly box gets the nod. If you're telling this story to an audience that wants goosebumps, you can still give them goosebumps without lying. Show Elon in a studio lit like a submarine, waving away aliens and pointing at supply chains. Show Joe's grin turn into the face you get when a simple idea tilts the furniture in your head. Rocks in the sky might be better mines than rocks in the ground, and a comet's breath is a shipping manifest. Cut from that to archival footage of meteorites cut open to reveal a metallic grain as tight as wood, sparks biting the saw. Then back to 3i Atlas as a ghost in a coronagraph, brightening, and the off-screen narration. We won't catch this one. We don't have to. It already told us what to build, and if you want a last quieter reason why this matters, set the music low and breathe with the facts. 3 times in a single human lifetime, we've watched a stranger from another star system cross our yard. The first time we argued about what it even was. The second time we were ready enough to taste chemistry. The third time, this time, we understood the assignment early. Listen, learn, and plan for the next. That curve, ignorance to instrument to intention, is the shape of a civilization waking up. 3i Atlas is not a test we pass or fail. It is a reminder that the road is real. The traffic is light but steady, and the only unforgivable mistake now is to treat the road like a rumour. So yes, the podcast clip will get the views. Yes, the word nickel sounds less romantic than alien, and infinitely more useful. But underneath the media churn is the steady drumbeat you can build a future on. Interstellar visitors exist. They carry ice and dust and sometimes metal. They pass too fast unless you're ready. Readiness is a choice, and the payoff is not only awe and energy, but answers to the oldest questions. That's why it matters. Not because 3i Atlas could have bankrolled a space tycoon if only we'd harpooned it, but because it pulled the curtain back and gave us the silhouette of what to do next. Workmanlike, scalable, a little boring in the best way. Build the truck, stock the lab, keep your shoes by the door. The road is out there, and the next headlight is already, invisibly, on its way. The first hint was a statistical itch. The track fit better if you admitted a nudge. Gravity alone drew a beautiful curve, yes, but the residuals, the tiny leftovers between prediction and reality, kept lining up in a way that made dynamicists frown. So they did what comet people always do. They told the model to allow for breath. When a sunlit hemisphere exhales, the gas leaves in jets that aren't symmetrical, and anything that isn't symmetrical becomes a steering wheel. The correction they added was small enough to make a pebble proud, but once it was there, the path settled, the numbers relaxed, and the orbit stopped buzzing like a wire in the wind. 3i Atlas, in other words, was doing what thawed things do, letting out air and shifting its weight a little as it did. That little can carry a lot of story. Vents don't open politely, they pop. They face odd directions. They switch on and off as the nucleus turns, so the thrust vector chases itself around like a minute hand. The result is a motion you can't see with your eyes but can feel in the math, like the way you learn someone's breathing pattern by the way a bed creaks. Some nights the push would have been mostly away from the sun, other nights mostly sideways. Add the possibility of thermal lag, the way buried ice takes a while to wake after sunrise, and you get a comet whose jets are a step out of sync with its daylight, like a dancer who's feeling the rhythm half a beat late. That lag reinforces a slow torque, changing the spin over weeks. If the rotation speeds up, weak seams can loosen. If it slows, other vents can dominate. You don't need fancy equations to follow the logic. Warmth makes gas, gas makes jets, jets make tiny thrusts make a measurable tilt in the path. Then came the colour gossip. In some frames, especially near the tightest solar angles, the light off the coma seemed to skew just a touch toward the blue, and a few observers whispered about unusually small dust grains or fresh ice crystals sparkling under cruel geometry. Others threw the flag. Instruments differ, angles matter, the solar wind loves to meddle. A glance that looks like blue can be forward scattered sunlight off very fine dust, masquerading as something exotic. The healthy thing in science is not the rumour but the wrestling. Teams cross-checked filters. They compared the same angles on older comets. They watched how the signal evolved after perihelion when the lighting changed. If the tint persisted with changing angles, that's a material clue. If it faded with the geometry, that's a lighting trick. Either way, the argument forces better data and more careful eyes. Solar weather played its part too. Charged particles streaming off the sun tug at ionized gas like wind teasing a flag, while the light itself acts like the faintest breeze on dust. Kinks in the gas tail, sudden bends, little disconnections. All of these can look like drama from the nucleus when they're just weather on the highway between. So the careful observers ran the same experiment twice, once in their heads, once in their code. If a hiccup in the solar wind swept across 3i Atlas right when the brightness tilted or the tail twitched, chalk one up to nature's mischief. If not, look again at the nucleus and its unruly lungs. You can tell a lot about a world by the way its scientists choose humility. The consensus that emerged wasn't mystery engine or alien sail, just the patient verdict these objects keep earning. Not everything that looks like a shove is a secret, and not everything gentle is simple. 3i Atlas almost certainly felt an extra hand on its back near the sun, the sum of vents and flakes and sunlight working on grains as small as smoke. That hand left fingerprints in the orbit fit and perhaps a faint signature in colour that will be argued about in conference hallways long after the public has moved on. To the people who study these things, that's the treasure. An argument narrowed by new facts, a guess sharpened into a test, a phenomenon they'll be able to compare the next time a stranger blows in from far away. Closer than you think, dimmer than you'd hope. That was the reality check that followed the fireworks of perihelion. On paper maps, the track of 3i Atlas crossed the same pages as the inner planets, and that makes the heart jump. In real life, close is not a feeling. It's a number so large that our language wears out before we finish saying it. The object passed at a generous remove, no headlines to write, no sirens to warm up. So generous that you could fit our familiar worlds between us and it, and still have room for arguments. Safe by any humane measure, and yet cosmically intimate. A one-time guest cutting across our field of view, with enough clarity to study but not enough blaze to make backyard legends. If you went outside hoping for a sword of light over the rooftops, the sky gave you humility instead. Even small telescopes needed patience. The trick was not aperture but technique, long exposures stacked like thin pages until the ink darkened, careful tracking that followed the object's slow drift instead of the stars, software that subtracted the crowded background to leave only the moving whisper. In cities, the haze ate it. In suburbs, the glow dimmed it. In deserts and on mountaintops, under the vault of the Milky Way, a faint cotton of coma could be teased from the noise on a screen long after your pupils had given up. If you saw it at all, you saw a suggestion, not a spectacle. And yet, dim is not the same as disappointing. The science lives in the quiet. Dim means the dust stayed fine and sparse. Dim means the nucleus was modest or the surface was dark. Dim means the outgassing never reached the geyser stage that turns a comet into a tabloid. That's a personality type, not a flaw. Some visitors arrive flamboyant, wearing tails as long as continents. Others slip past dressed in ash, clutching their chemistry tight, letting out only enough breath to make a halo you have to coax from the pixels. 3i Atlas was the second kind, introverted, disciplined, reluctant to pose. The nearness we felt came from participation, not proximity. 1,000,000 screens refreshed, orbit diagrams updated, amateur forums filled with stacked images and short-lived triumphs. People who had never cared about the word's phase angle found themselves learning why the same dust looks brighter when you're looking almost into the sun than when you're looking from the side. People who had never thought about opposition surge ended up with a layperson's sense for why a grey moon glows like a lantern when the shadows vanish. That education is a kind of closeness no ephemeris can plot. You became part of the measuring instrument the moment you tried to see it. There was a quieter intimacy too for the small crews at professional observatories. They had to time their shots between dawn's creep and dusk's return. They had to negotiate with the moon. They had to work around the fickle moods of air. They scheduled the big glass for the minutes that mattered, not because 3i Atlas was headline bright, but because modest light, captured cleanly, can answer better questions than great light smeared by haste. In the logs you can almost hear the hush, object acquired, coma detected, tail faint, sunward asymmetry slight. It reads like a diary of restraint. Closer than you think earns one more translation. We live in the same system, share the same star, sweep through the same ocean of dust. When an interstellar wanderer threads that ocean, it uses our gravity and our light as reference points the way a ship uses a lighthouse. You don't have to dock with the ship to feel included. The physics that shaped its curve is the same physics that keeps Earth steady under our feet. Watching 3i Atlas skim the inner system is a reminder that we're not tucked away in a corner of nothing. We're parked at a junction on a road others occasionally travel. So the spectacle you didn't get in the sky becomes a spectacle you can stage in the mind. Picture a theatre lit only by a match. The actor crosses the stage in 30 beats, face and shadow, breath barely visible. If you sit close and lean forward, you catch the profile, the exhale, the glitter of dust in the light. If you sit far back, you hear the hush and miss the face. 3i Atlas offered that kind of show. Private if you wanted it to be. Public only if you knew how to look. Dim, yes. But the kind of dim that carries more truth than a roar. Close, yes. But the kind of close that reminds you how big the room really is. The message wasn't words, it was ratios. When sunlight hit the faint atmosphere around 3i Atlas, the molecules that boiled off the surface behaved like tiny bells, each ringing at its own pitch. Instruments listened to those pitches and heard an old refrain. Water in the lead, but not alone. Shadows of carbon-bearing gases, traces that betray how much heat touched this body when it was young. You don't need the exact names to feel the plot. Some ingredients prefer cold nurseries, others need a little warmth before they settle into the mix. The proportions between them are a birth certificate. Dust spoke too. Every grain is a diary fragment. Glassy where it once melted and cooled, fluffy where it never knew a furnace, flecked with metals here, smeared with organics there. When starlight scattered off that dust, it changed the colour and texture of the glow in ways that only careful eyes can see. From that texture, you can tell whether the grains are small like smoke or big like sand, whether they clump or travel alone, whether they are coated in carbon-rich varnish or rubbed clean by time. 3i Atlas held those clues as tightly as a fist at first, then loosened its grip as Perihelion heat coaxed more material into the light. Comparisons made the message legible. We've listened to comets born in the deep freeze of our own outskirts, and they hum a song we've come to know. 3i Atlas hummed in that same key but bent a few notes. A little more of this, a little less of that. A subtle shift that suggests its nursery mixed the gas, dust and sunlight on a slightly different schedule. Is that difference small? Yes, and that's why it's huge. When you're asking what the galaxy likes to build for planets and atmospheres, a tilt in the recipe matters more than a headline. It tells you whether worlds like ours are a common accident or a rare trick. Even the water had stories tucked inside it. Not all water is the same. Some is a breath heavier, some a breath lighter, depending on how and where it formed. You can't taste that difference with your tongue, but instruments can, and that taste whispers about temperatures and timelines in a cradle star system we will never visit. If 3i Atlas leaned one way or another, it tugged the needle on the question that won't leave us alone. Is our ocean an ordinary ocean by galactic standards, or a special brew? And then there were the carbon compounds. Nothing dramatic to the naked eye, but there in the glow, simple chains, rings, the modest, sturdy stuff that, given a planet and time, becomes feedstock for chemistry that learns to copy itself. One comet is not a promise, but every time we smell those molecules in a traveller from somewhere else, the map of possible gets a little thicker with ink. Add dust grains that look as if they once felt enough heat to tidy up their structure, and enough cold to preserve it, and you get a picture of materials that have toured through changing neighbourhoods, exactly the journeys that churn complexity out of simplicity. The instruments that made these inferences are not romantic machines. They count, subtract, calibrate, and confess their uncertainties loudly. Ground-based telescopes took the night air's turbulence into account. Space-based eyes did their work above the weather. Observers built their case out of many small agreements rather than one loud claim. A gentle rise here, a repeating colour change there, a persistence of a line that should vanish if dust were the only player. The most exciting parts of the message were the parts that survived every attempt to explain them away. By the time 3i Atlas was turning outward again, the chorus had settled into a cautious clarity. It is an interstellar comet by temperament and by chemistry. Ice that wakes in sunlight, dust that loosens with breath, a faint coma that grows and fades with distance. But it is not a perfect echo of the comets we know. Somewhere in its depths, the balance of volatiles and solids, the size of grains, the seasoning of organics, leaned just enough that if you laid graphs on a table, the lines wouldn't stack. They'd weave. That weave is the letter it carried across the void. Not a message for us exactly, but a message we could read. The galaxy's kitchens bake many breads. Ours is one of them, not the whole menu. All of that science has a human aftertaste. Someone sat through a clouded night watching a star's light, flattened just enough to believe the subtraction worked. Someone wrote tentative, and then struck it later and felt the small rush of turning a hunch into a result. Teams that otherwise compete passed data quietly, because the object would never come back, and there was no time to be proud. The chemistry didn't just tell us about a distant nursery, it told us about ourselves, that we can be patient, skeptical, and still open to wonder all at once when the universe gives us something fragile to hear. Outward is a direction and a mood. When 3i Atlas rounded the sun and began to fade, the story didn't stop. It thinned into the kind of thread you have to follow with your fingertips. The coma cooled, the jets dialed down, the dust fanned into a softer, lazier plume. Each night the measurements took a little more work, the stack of exposures needed a few more pages, the software had to squint harder to tease signal from the murmur. That's how visitors leave, not with a curtain drop but with a long dissolve. The orbit diagrams, the tidy loops and one deliberate open curve, became a kind of map with a scratch across it. That scratch is the exit wound the sky will wear in our records. An arc of positions, a trail of light, the pattern of a one-time crossing that future students will point to in lectures and say, there. In the big picture, nothing changed. Planets kept their appointments. The sun burned like a clock. But in the ledger of things, we know rather than guess, a new line was written. And that is how the universe actually changes for us, quietly, through entries. What remains after the visitor is work. Observers return to the raw frames and re-reduce them with better calibrations. A small bug discovered in a pipeline retroactively sharpens a faint line. A new dust model makes an old brightness curve make more sense. The debate about the perihelion flare settles into language as modest as it is consequential. A catalogue of grains drawn from polarized light, a way of saying how a glow is oriented, earns a footnote that will save someone else months in the future. This is the part of the film where the music is low and the cuts are of people typing, sipping cold coffee, and nodding at plots. For the wider world, the comet is gone. For the people who listened closely, it's everywhere. It hides in talks given to sleepy undergrads who perk up at the phrase, "from another star." It lives in proposals for Sentry spacecraft that would loiter far from the sun, ready to pounce when the next alarm rings. It resurfaces in a meeting about how to keep a heavy-lift rocket on hot standby, not for a Mars shot, but for a sprint toward a new stranger with a box of cameras and a drill small enough to matter. 3i Atlas becomes an argument for routine, not spectacle. Survey deeper, publish faster, keep a packed bag in orbit. There is poetry still, even in the paperwork. The path 3i Atlas carved through our system will never be repeated, but it rhymes with paths taken by others we've seen and those we will see. If you overlay them, you get a faint mesh, a suggestion of the great traffic lanes that connect star to star. Maybe, years from now, that mesh will be dense, and we'll talk about interstellar objects the way sailors talk about seasonal winds. Maybe we'll even build harbours for them. Observation posts, small drones perched in the dark, waiting to fall in step with a passerby long enough to touch, sniff, and send home real samples instead of light. Even without that future, the exit matters. When a traveller leaves a room, the air changes, and you notice the shape of the quiet it leaves behind. In this case, the quiet is richer than the noise that came before it. Before we were guessing what an interstellar comet might be like. Now we can compare guests. One came dry and angular, another wet and dusty. This one's something in between in a way we didn't predict. The space between those descriptions is where new ideas live. It narrows what theories can say with a straight face. It tells us which stories about planet-forming disks belong on the shelf and which belong in the recycling. You can end the chapter honestly by looking up, even if there's nothing to see. Somewhere out past the orbit diagrams and the easy metaphors, 3i Atlas is cooling back into itself, its skin tightening against the cold, its breath stopped. It carries our sunlight on its back like a fading bruise and points toward distances we name with more zeros than we can feel. We won't see it again. That's fine. What we needed from it is here. A handful of clean measurements, an image of dust and gas telling truths under a hard star, a reminder that we live beside a road and not at the end of one. And if you want a closing image that doesn't lie, picture the solar system as a pond at dusk. A skim of insects writes temporary calligraphy on the surface. A single, faster stranger cuts a line across and is gone. The water closes, but the ripples carry news of speed, of direction, of shape. 3i Atlas was one such line. We have the ripples now, in data, in memory, in a plan taped to the wall that says, the next time we feel this tremor coming down the road, we'll be ready to meet it not only with telescopes, but with hands.